Hello everyone, and I welcome you all. Good evening to all of you. Can you guys see me and hear me clearly? Am I audible and visible clear enough? Please tell me. Please let me know. Am I audible and visible to all of you? Sure? Say something at least. Mark your presence in the chat box. Good evening. Thank you. Good evening. Very good evening. Please share this session. Actually, my Telegram is not working. I don't know why. Some problem is there and I'm not able to access it. Recently I had to change my phone because the old one broke, and I'm not able to restore my Telegram. Two-stage inscription and something was there. So that's the reason. I love you too. I love you 3000. Not 3000, 3 lakh crore thousand. Anyways, please share this session. At least make it 30 or 40 something students, so that the ones who are at least English speaking can have these questions. And let me tell you, the next session will be on applications of thermodynamics, will be taken by me only. Apart from that, on this channel I'll be also taking heat transfer. Then on the main channel, heat transfer applications and thermodynamics. So in total I'll be not giving you 10 questions only. I'll be giving you 10 10 10 10 10 10, in total 60 questions. Okay, love from Jaipur. Good evening, good evening, good evening, very good evening. So please share this session. And actually today there will be 11 questions. I'll be dealing with you in 11 questions. I'll be telling you 11 questions. The 11th question I'll be giving you as your assignment, you can say, and the answer you have to tell in the comment box. And in the next thermodynamics session on main channel in Hindi, I'll tell you what the answer is, what the solution is. Okay, so this is going to be something interactive. We are going to interact with each other in this manner only, because YouTube allows us to do that only. So please share it, keep sharing it, my dear students. In just a moment or two we are going to start. Okay, please keep sharing it and we shall start it right now. Okay, so we'll start with a question, and that question I'm going to write over here, right? I'm going to write over here. See, it's a very important question, and it has been, you know, in the many of the test series and all. So please see, a Carnot engine receives 20 kilojoule heat from a source at steam point and rejects to a sink at ice point of water. Okay, what will be the location of absolute zero on Celsius scale? Okay, so this is the question, and it's a very good question. This has been there in many of the test series, and it is one of the very good questions of PK. It's not that I will make you, note these questions. It's not like that. I have all these questions. Just this question came into my mind. That's why I'm telling you this. Okay. Somehow it skipped while I was preparing the questions. So today's questions are bumper questions, let me tell you. These questions are like too damn good. Please, 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 I request you guys to try these questions one by one. Kindly try this question out. I'm giving you 2 to 3 minutes of time. In these 2 to 3 minutes of time, you have to try this question. And please share this session, yaar. I mean, I have to prepare all these questions and all for you, the solutions and all and everything. So all you can do is at least share these sessions so that maximum can get benefit out of it. Aditya sir is here in the chat. Welcome, sir. You really are on fire, Aditya sir. Okay. So, shall we? Thank you so much, sir. That's your love. Okay. So, let's see the solution. Let's see its solution, which is very easy once we see. So, reject heat or work output given. Not needed. Pinto, it is not needed. It is not needed at all. You'll see why it is not needed. Okay. So, shall I start? Or you want 1 or 2 more minutes? A couple of more minutes you want? Or you want me to do it? Minus 273 is absolutely wrong, Ashutosh. It is absolutely wrong. So, it's really heartbreaking. The number of students which I can see. Anyways, a Carnot engine receives 20 kilojoule heat from a source at steam point and rejects to a sink at ice point of water. What will be the location? Please see. This is steam point 100 degrees Celsius, right? And this is the Carnot engine, and it is receiving 20 kilojoule. Am I right? Some work will be output, and this is your 0 degrees Celsius. Am I right? Okay. Now, please pay attention. This is how it is working. Now it is asking location of absolute zero. If it is asking the location of absolute zero, then clearly it is not talking in terms of Kelvin scale, right? It is not talking in terms of Kelvin scale. Please pay attention. It is not at all talking in terms of Kelvin scale. Why it is not talking in terms of Kelvin scale? Because then it would be a straightforward question, right? Getting my point? It is not talking in terms of, yeah, exactly. It is not talking in terms of Kelvin scale, my dear. Then it would have been some other. Yes or no? Great. No problem. Okay. Okay. I think one more one more data must have been given, but let's see. So let the location of absolute zero on Celsius scale be Celsius scale be minus T, right? Therefore, absolute temperature will be, so what will be the values of absolute temperatures? Then it will be 100 plus T of the source, and it will be 0 plus T of the sink. Don't you think? For example, in Kelvin, the location was minus 273.15 degrees Celsius. That's why we added 273.15, right? So if the location is minus T now, we'll add T. That's what we are going to do. It is as simple. Hence, this is the case. So in reality, it is T. T. Am I right? Of course, I'm right. Anyways, so let's talk about the first law of thermodynamics. What's this first law of thermodynamics? 20 equals W plus Q2. Equation number 1. And then you have Clausius. Clausius inequality over here becomes equality because it is reversible. This becomes 0. I want you guys to please take a note of it. Take a screenshot, please. Kindly take a screenshot, then we shall move forward. Please take a screenshot. क्वेश्चन में पूछा गया है, समझ में नहीं आया, बता रहा हूं. एक बार सॉल्यूशन मुझे कर लेने दो. जस्ट लाइक आफ्टर द सॉल्यूशन यू विल गेट द रिजल्ट. खुश रहिए राज. ओके, नाउ सो व्हाट इज इट? Del Q by T reversible, am I right? So del Q is 20 kilojoule is coming at 100 plus T, minus it is going Q2 at what? 0 plus T equals 0, means 20 upon 100 plus T equals Q2 over T. Am I right? So at least one thing must also have been given, and yes, Singh and rejects 14.6 kilojoule. Let us do it 14.6 kilojoule. This is 14.6 kilojoule. So 14.6 kilojoule is being rejected. Now please pay attention. Please pay attention. Please pay attention. What is happening? In this question, there is a Carnot engine given, right? Please pay attention. There is a Carnot engine given in this question. What happens? It is saying that receiver, supplier is 100 at 100 degrees Celsius. Receiver is at 0 degrees Celsius. This much clear? This much clear? Now, if supplier is at 100, then what do I have to do? I have to add something to make it absolute. And clearly, the absolute temperature scale over here is not Kelvin. Why it is not Kelvin? The reason for it not being Kelvin scale is very simple, that if it were Kelvin, it won't have asked location of absolute 0, because it would have been simply minus 273.15. See, what I'm trying to say is, there is not only one absolute Kelvin scale, absolute temperature scale. Kelvin scale is one of the absolute temperature scales. For example, there is Rankine scale also. Rankine scale is also an absolute Kelvin scale, absolute thermodynamics temperature scale. It is just that we adopt Kelvin scale. So that's why broadly we say that okay, Kelvin is there, right? It is just that there is a breed of dogs known as German Shepherd, but German Shepherd is not the only breed of the dogs, right? We know it very commonly because it's a general adopted convention is that most of the people go and adopt that pet, especially that breed, German Shepherd. Yes or no? In the same way, Kelvin scale is one of the absolute temperature scales. It is not the only absolute temperature scale. It is one of the absolute temperature scales. So if it is one of the absolute temperature scales, here it is asking what is the location of absolute 0. It means that in this case, in this question, it is asking about some other temperature scale, some other absolute temperature scale. Now understood, Raghavendra? Now understood? So, if that is the scenario, we are assuming that the location is at minus T. Location is where? Minus T degrees Celsius or minus T, right? It is present at minus T. Let us recall about Kelvin. The location of absolute 0 and Kelvin absolute 0 Kelvin on Celsius was minus 273. That's why we added 273. Here we are assuming minus T. That's why we have to add T. Now it becomes some absolute temperature scale. It is not Kelvin scale. It is some absolute thermodynamic temperature scale. Same way, here also we have to add T. In the question, this data was missing. Now it is complete. 14.6 kilojoules. Understood, everyone? Understood, everyone? Great. So if we are able to calculate this T, tada, done. So therefore, actually, there would have been 3 variables, 1, 2, 3, T. That's why, and only we have 2 equations. So one more data has to be given. That was given as 14.2. Okay? Okay. Now, over here we have 14.6. Now can you solve it? Of course you can. Of course you can. Please check, T must be coming as 270.39. Right? 270.39. Therefore, the location is minus T. Hence, the answer will be minus 270.39 degrees Celsius. Why I included this question? Because this question is of utmost importance. I included this question because this question, namaste, namaste, namaste Rishabh, because this question is of utmost importance. Now why this question is of, acha, one more thing. Many people might have not joined because they might have thought that I am going to deal with same questions in Hindi channel as well. No, that is a straightforward no. Okay, that is a straightforward no. Other 10 questions, 10 other different questions will be dealt in Hindi channel. Please pay attention. Please mark my words. Okay. So whatever questions I am dealing here, whichever questions, I am not going to repeat them over there. Understood? Right. So yeah, so the location is minus T, hence it is minus 270.39 degree Celsius. That is the location. Yeah, this is the very first question. We have completed it. Understood, everybody? So this kind of question might be asked, and this kind of questions might be asked just in order to confuse you. You'll get definitely confused. Ah, sir, we have no. Kelvin scale is the absolute thermodynamic scale, temperature scale, but it is not the only absolute thermodynamic temperature scale. Got it now? I hope it is clear to all of you. I hope it is clear to all of you. Is it clear, my dear students? Please take a note of it, or you can take the screenshot as well. Kindly take the screenshot. Why you are taking minus T? Because this is your Celsius scale. What's the other name for Celsius? Centigrade. Means this scale is in the divisions of 1 till 100. Am I right? So this is the zero value on Celsius. But is it the absolute? No. We have to go to this side. Hence towards the minus side. Hence the location will be at minus T. Understood? Because 0 is not the minimum one. That's why it is minus T. Got it now, Ashutosh? Clear, no? Very beautiful question. Good question indeed. Next. It's a common data question. Common data question. And I want you guys to please deal with it. Common data question. I am giving you some time. Please try this question. Kindly try this question. 1.2 centimeter diameter stainless steel ball, means ball bearing means spherical, are quenched in water at a rate of 1400 per minute. Means what? There are 1400 balls which are being quenched per minute. In a single minute, 1400 balls are being quenched. The balls are leaving the oven uniformly at 900 degrees Celsius. They are exposed to air at 30 degrees Celsius. That is the cooling temperature. For a while prior to quenching, and the temperature of the balls drop to 850 degrees Celsius when they are in air. For stainless steel, use the density as this much and Cp as this much. What will be the rate of heat transfer to the air? There is a question mark, not 9. My mistake. It's a very beautiful and easy kind of question at the same time. What will be the rate of entropy generation due to heat loss from the balls to the air? I want you guys to please do this question. Kindly do this question. Would you try this question? Please do it. Are you doing it? You want some more time or you want me to do it? You want some more time or you want me to do it? You did. Tell me the answer then. Tell me the answer then. Please tell me the answer then. B, A. B and A. We'll see. We'll see. A. This is A. You are saying this is A. Let's see. So first of all, we should know what is the mass. Mass is density times volume. What is density? 8085. And what is the volume? 4 by 3. Diameter is given. So pi by 6 d cube. Am I right? 1.2 times 10 to the power minus 2 cube. Yes or no? Diameter cube, pi by 6 d cube, no? So mass shall be this is 8085 times pi by 6 times D is diameter steel balls. D is 1.2 centimeter it is. So meter it is 10 to the power minus 2 whole cube. Is this the one? What is the mass coming out to be? Can you tell me? Acha, I can, this will be mass flow rate sort of, right? Mass flow rate into 1400 upon 60. In 1 second, how much balls are quenched? This will give you how much balls are quenched. Yes or no? So total mass shall be, total mass or m dot shall be, just a minute, times minus 6 times 8085. 0.0073. Let's do this. I mean, not total. Let's not calculate total. M shall be 0.007315 kg. Am I right? Am I right? Heat transfer from the balls to the air. So Q will be MC delta T in the from the balls to air. Right? That means what is M? M over there is 0.007315 into specific heat is 0.480 and it is 900 minus 850. Why? Because in You will not take 900 minus 30. That will be wrong. Because in the air, although the air temperature is 30, but it is dropping to 850. After that it is quenched. Like for example, this is the furnace, and from here the ball bearings are coming out and they are going to be quenched in this tank, right? So when they are here, what is the heat rejection? That's what we want to calculate. Understood, my dear? Got it? 50 1400 over 60, 4.0964. That is Q shall be, this Q shall be 0.1755 kilojoule. But if you want to calculate total by all the balls, you have to multiply N. What is N? N is 1400 in a minute, then in a second it will be 1400 by 60 times 0.1755, and that is 4.0965 kilowatt, which is close to 4.1 kilowatt. Understood, everyone? So that's your option number A. Is it clear? That is your option number A. Is it understood? Please take a note of it. Kindly take a note of it. I am humbly requesting you. Please do it. Done? Done? This question. Try this question now. Try this one. Try the other one. What will be the rate of entropy generation due to heat loss from the balls to the air? So it will, basically it is asking not the rate of entropy generation, but the rate of delta S of universe. It is asking you that. The rate of entropy change of the universe, basically it is asking. Yes or no? So please do it. Please do it. Shall I do it? कराऊं मैं? Tell me guys, you want me to do it? You guys want me to do it? Please tell me. हाँ जी. Okay. Now, tell me guys. Wait, I should wait. Okay, I'm waiting. Option number C. I think it is correct. Think it is correct. Chalo. See, enough time. Rate of entropy generation. Why it is delta S dot universe? The reason for it, please pay attention. Please pay attention to the wording. Otherwise, you will calculate only one and you will end up having a wrong answer. Okay? So please pay attention to the wording of the question. Due to heat loss from the balls to the air. Heat is being lost from the balls to the air. Mind you, from the balls to the air. What does it mean? What does it mean from the balls to the air? From the balls to the air. It means that there are going to be changes in the property of the ball, which is, we have seen already, from 900 degrees Celsius to 850 degrees Celsius. And also, since the heat is being going to air, which is the surroundings, so it will bring about some changes in the surroundings as well. So hence it is delta S universe. Got it? Not only entropy generation. This is actually delta S universe. Hope you understand. Let's see. So what is delta S dot universe? This shall be delta S of the system plus delta S of the surroundings. Am I right? Yes. This is for the balls plus delta S of the air. Now, since stainless steel is solid, means it is incompressible, it means that dV is 0, change in volume is not there, it is 0. If it is 0, I can apply TdS equals du plus PdV very easily. Also you can apply dH minus VdP. Why? Because the surroundings pressure is same, it is not changing. Hence, so ds can be written as m dot ds dot, right, m dot Cp dt over T, and delta S dot, if you solve it for steel ball, will be equal to m dot Cp ln final temperature over initial temperature. What is m dot over here? M dot is, we have calculated already. Baba, we have calculated already. If not, let me tell you, 1400 by 60, then only it will come in kilowatts here. 1400 by 60 into what was there, pi by 6 times 1.2 times 10 to the power minus 2 cube. Am I right? Then after 8085, then you have Cp. How much is your Cp? 0.480 it is, of course, 0.480 ln 850 is 1123, this is 1173, 900. So that is your delta S of steel ball, delta S dash dot of steel ball. So this should be, let me do this for you. Okay, so pi by 6 10 to the power minus 6 8085 times 1400 by 60. Okay, this much is done, times 0.480 times ln of 1123 by 1173. So this is minus 0.003 357, I should rather say, kilowatt per Kelvin. Is it clear? राइट सर, इसमें बस प्रॉब्लम ये है कि पॉइंट के बाद भी 7-8 डिजिट, हाँ तो वो रखनी पड़ेगी. डेल्टा एस ऑफ सराउंडिंग्स del q dot by t not. Am I right? So what is del q dot over here? Del q dot, where is it? We have calculated actually, because that much amount of heat is going to air, no? 4.1, yes or no? That is 4.1 is going out to the air, so it will be 4.1 over temperature was 30, no? 303. So it is positive 303. So it is 0.01353 kilowatts per Kelvin. So delta S dot of the universe, you just add them up, it becomes 0.00357, 0.009961. Unit is kilowatts per Kelvin. That's your answer, my dear students. Delta S dot of the universe. 95. Yeah, this is correct. Is it clear, everyone? Yes or no? That's what I have kept. Denominator as ambient temperature. Understood, everyone? Understood, everyone? Please tell me. Say yes or no. Understood, everybody? Shall we move forward? It was a good question. It was calculative one. And if you know that it is calculative in nature, and if you know that basic concepts of entropy, you shall be able to do them, right? Shall we move on to the next one? Please take a screenshot of it. Kindly take a screenshot, then we shall be moving forward. Kindly take a screenshot, then we shall be moving forward. Done? Okay. Next question. This one is also good one. Please try and do this. Please try and do this. This also belongs to entropy. Total entropy. See, are you understanding why I included this question? Because here it is not saying directly delta S universe. No. Here also it is not saying directly delta S universe. Right? Please take it. Note, do it. Please do it. I'm giving you some 3 to 4 minutes of time. Kindly do this. Is it done, students? Please tell me. Is it done or what? Or you want me to wait? Kindly tell me. D. Let's see what the answer is. I don't think so. D should be there. Anywho, if you are able to understand what is being asked in the question, Total entropy change means delta S universe. What is being asked? Delta S of universe is what? Yes or no? If it is being asked that what is the delta S universe, delta S of universe, then automatically these two options are incorrect. Getting my point? Finish. Now, these two, and there is not even a close competition between them. So let's move on. Let's say you have a lake which is full, and in this lake you have iron block and copper block. This is copper, this is iron. So if heat is being lost to the surroundings, that is lake water, don't you think water is also being affected? Yes or no? So surroundings is also being affected. That is why copper plus iron plus surroundings, all these will come. You understanding my point? Copper plus surroundings plus iron, all these will come. And option number C is absolutely correct, Pinto. Good, very good. So now how to solve this? Two blocks of iron and copper, both initially at 80. Ti of copper, Ti of iron. Both are equal. Large lake. Large lake means what? Infinite capacity. And if the lake is large, capacity is infinite, that means lake temperature won't change. I have explained it to you while we were studying thermodynamics, right? Infinity, T infinity or T final, both 15 degrees Celsius. Masses are given, mass of iron block and that of copper block. After a while, the system are in thermal equilibrium due to heat transfer between blocks and lake water. It means what? After some time, from 80, both of them have achieved lake temperature 15 degrees Celsius. Now the entropy change. So delta S universe shall be delta S system plus delta S surroundings and plus delta S system plus surrounding. If that is the scene, then delta S system contains delta S Fe, delta S Cu plus delta S surroundings. Am I right? If that is the case, then let us deal with them. Right? Both iron and copper are incompressible because they are solids. Hence they are incompressibles. Yes or no? They are solids, hence incompressibles. If solids and they are incompressibles, it means what? You can apply TdS equals du plus PdV very easily. Do it as 0. Means your ds shall be mc dt over t and your delta S shall be mc ln final temperature over initial temperature. That is how it is going to be. Am I right? Now, so delta S of iron will be, what is mass of iron? 50, I guess. What is the specific heat of iron? 0.45. And the changes are 80 to 15. Final temperature is 15, that is 288. And the initial temperature over there is 80. Means 353. Am I right? Great. That of copper shall be 20 times 0.386 ln. This is also reaching 288 only from 353. That's great. Now what about delta S surroundings or lake water? That is your del Q over T lake or T naught or T surroundings. Now what is this del Q? Del Q is total del Q heat lost by copper plus heat lost by iron. Both are going to the lake only. So that's how it is going to be. I want you guys to please take a screenshot. हाँ तो गलत किया था ना. I want you guys to please take a screenshot. Have you guys done it? Kindly take a screenshot. Then we shall be moving forward. Right? Then we shall be moving forward. Okay. So let us see. Let us see. Now it will be delta S surroundings or lake shall be, what is lost by iron? 50 times Cp. Cp is 0.45 times 80 minus 15 plus that by copper is 20 times 0.386 and times 80 minus 15 upon में it is 288. So I think this will be calculated. All these will be calculated. You can calculate delta S universe, and delta S universe shall come 0.7670 joules per Kelvin, kilojoules per Kelvin. This you will get. Please check it. You will get this. Trust me. It is asking total, no? Total in the process is of the lake, of the copper and iron both. So please tell one thing, entropy generation of surrounding का क्या मतलब होता है? Generation is due to internal reversibility of the system, ना? See, entropy generation of the surrounding is another way of saying entropy change of the surrounding. Entropy generation of the surrounding is nothing but entropy change of the surrounding only. So don't worry about it. Okay? Understood? Yeah. So doing it, you will get that. Understood, everyone? Is it clear? Any doubts till now? Take a screenshot, please. I want you guys to please take a screenshot, then we shall be moving forward. Kindly take a screenshot. Okay? Shall we? Next question is also good one. Please try this up. I want you guys to please try this question. Doing, guys? Please do it. It's a good question. No problem, Sai. It's okay. Start from this question only. Please try this question. It's a very good one. Gas is ideal. You have to consider it as ideal, even if it is not given, because there is no other expression for real gas given, right? So it is your, what do you say? You have to do it, right? There is no other option with you. You'll have to do it. No other option. Should I start? Or what? Okay. Let's see. In the figure shown, hot combustion gases enter the nozzle at this much temperature V1, T1, P1, exit at P2, T2 and V2. Great. Assuming the nozzle to be adiabatic, del Q is 0 and surroundings to be at 20 T naught. The decrease in exergy, oh my god, decrease in exergy. What shall be the decrease in exergy? How much is the decrease in exergy? Good question. Assuming the nozzle to be adiabatic, means adiabatic expansion is taking place. K is given, gamma K. The value of R is given and that of Cp is given as well. Yes? So how to do this? The question, real question is how to do this. Okay. Try it, guys. 1 more minute I am giving you. 1 more minute I am giving you. No? Shall I do it then? A. Let's see. A or B, what it is. Let's see. See, first of all, it is a nozzle. And when there is a nozzle, there is no work output. There is no work output of it. Sir, then how can we talk about exergy here? Because exergy in this case, exergy in any case, is maximum obtainable work availability. That is what exergy is. Say yes or no. So the very first confusion which you guys might be having, sir, how exergy? Right. Now, if you talk about exergy here, want to talk about exergy here, let's talk about in terms of phi 1 and phi 2. What is total energy available at inlet and available at outlet? What is the difference between them? Okay. Here, there will be some flow availability. Phi is what? Flow availability. Availability or availability function. So what does it tell? It is telling you maximum obtainable work, which is nothing but exergy at any state. Yes or no? So phi 1 will be maximum obtainable work at inlet or exergy at inlet I, and phi 2 shall be maximum obtainable work at exit, or basically exergy at exit. That is what it is. So if you do the difference, tada, yes or no? If you do the difference, done, no problem. Are you getting my point? If you do the difference, done, baba. So loss in exergy. Acha, you might be wondering, sir, why there is a loss in exergy at all? Because nozzle is energy transformation device. In this, there is no energy transfer but transformation. Pressure energy gets converted into kinetic energy. That's what happens. So it is a transformation device. Why the hell in an energy transformation device are we observing loss in exergy? Right? Because it simply tells you the form in which energy available over here, T is more, temperature is more enthalpy you have, more work you can obtain. T is less work you can obtain. So that's why there is a loss in exergy. Understood? Feeling got the feeling or not? See, the question is very simple. I mean, solution if I do, I'll explain it in 2 lines and I'll move forward. But I want you guys to have the feeling of this question so that you can think about it. Right? Understood now? Kindly take a screenshot of it. Then only we shall be able to move forward. Please take a screenshot of it, my dear students. Please take a screenshot of it. Energy degraded. That's right. Hanji, taken the screenshot? Have you guys taken the screenshot? No problem. Let's move forward. So what is phi? For an open system, I have taught you this. Phi is H minus T naught S. Yes or no? H minus T naught S. That is your phi. But only if kinetic energy and potential energies are neglected. Yes or no? Yes or no? Are you getting my point? That is, if kinetic and potential energies are taken, then phi open system is H minus T naught S plus V squared by 2 plus GZ will be there. Understood? Got the feeling? What do you want this video to be, private or public? I think I should make it private. Then only more students will be, attentive. Understood na? Understood na? We'll see how your answer is going to be same or different, Raghvendra. Just wait for a few moments. Please understand the beauty of this equation, right? Because kinetic and potential energies can be converted, no? This kinetic and potential energies can be converted, no? So that's why I've added them up. If not given, remove them. If given, then take them. Bingo. Yes or no? Not mad angles. So phi 1 shall be H1 minus T naught S1 plus V1 squared over 2000 plus GZ1. Then you have phi 2 H2 minus T naught S2 plus V2 squared over 2000 plus GZ2. Am I right, my dear students? Of course I'm right, I know that. Now take the difference, minus, minus, plus, minus, minus. So it is phi 1 minus phi 2, right? So that is your H1 minus H2. Minus T naught I am taking as common. That shall be S1 minus S2. Plus V1 squared minus V2 squared over 2000 plus G Z1 minus Z2, right? Since Z1 Z2 are not given, these Z1 and Z2 values are not given, then phi1 minus phi2 becomes what? This becomes, my dear, h1 minus h2. Got this beautiful equation? Got the, logic behind this beautiful equation? Please tell me, my dear students, is it understood to all of you? Yes or no? Now can you calculate? Of course you can. Now can you calculate? Yes or no? That's the beauty. Fine. Phi1 minus phi2 is Cp T1 minus T2 minus T0 S1 minus S2 we have to calculate plus V1 squared minus V2 squared over 2000. I need you guys to please take a note of it or take a screenshot. Maza aa raha hai ya nahi? Bolo. Tell me. Are you guys able to understand this, or yes or no? Done? Shall we move forward? Got it? You have to think about it in this way, right? If you are able to think about the questions in this way, no problem will be there ever. So let's remember the values. 1.15. Okay, CP is 1.15. Okay. Now, TDS equals DH minus VDP. Why? Because changes in pressure and temperature are given directly. So DS shall be Cp dt over T minus R dP by V. This will become V by T will become R by P, and you can do that. Replacing can be done, substitution can be done. So now this is your DS, right? This is your DS Cp dt by T. Now delta S shall be Cp ln T final by T initial minus R ln P final over P initial, right? But if you are calculating 1 minus 2, then it will be, because integration will be from 2 to 1, so it will be Cp ln T1 over T2 minus R ln P1 over P2. That's how it will be, because it is 1 to 2. So 1 by 2, 1 by 2. Final initial. Got it? So S1 minus S2 shall become 1.15 ln. What all are the temperatures? Final temperature is, I guess, 500, means 773. And initial one is, I don't remember what exact value is, 747. 747, right? It is 747. Means you add 73. So 47, 73, 20 and 700, 1020. Right? Check it. This will be the case. Okay. Minus. What is R? 70, 260. R is 2654. 2654. Upon 70.2654. The unit is same, yes or no? Let's check. 260 kilopascal, 70 kilopascal. Good. So from here we can calculate S1 minus S2. Let us do that. Whatever be the case, let us calculate it. Why we use entropy change formula for reversible process and irreversible process? I mean, let me tell you, the entropy change formula contains, I have told you already, only properties. And property change is same whether it is reversible process or irreversible process. It doesn't depend on that. Understood? So that is the reason why we did it. Got it? 1.15. That is 0.31887 minus, okay, times 0.2654, 0.34825. So S1 minus S2 shall be 0.31887, 0.02938. This is unit shall be kilojoule per kg of Kelvin. Yes or no? So that, my dear students, is your S1 minus S2. Now please calculate. Phi 1 minus phi 2 is 1.15. 747 minus 500 minus T naught. How much was T naught? Surroundings temperature, I guess 20 degrees Celsius it was. 20, yeah, 20 it is. Okay. So it is 293 times minus 0.02938. Okay, plus V1 was, I guess, 60 or something. Let me calculate it. 80 and 768. Okay, 80 and 768. 80, 768 over 2000. So overall phi 1 minus phi 2 you can calculate. Let's do it. Got it? 7 minus 500. Just a moment. 768. 2000. 0.947 something it is coming. Is it? 0.947 something it is coming. 0.947 something is coming. Please you calculate and tell me. You calculate it and tell me. Am I right or am I wrong? $80 minus 768 by 2000. Okay, plus 298 times 0.02938. Okay, plus 293 times 0.02938. Okay, and plus 1.15 times 247. 0.946 it is coming. Yeah, it means, Vishal, that these are important. It means that these are important. Yes, it really means that these are important ones. What is the answer coming out to be? Hmm? Point nine something, no? 0.94634. Correct. So I was thinking that it is not matching. 94634 kilojoule per kg. Now it is correct. This much exergy is lost. And by the way, options given are not correct. Your solution is correct, right? So no problem. I was confused by the option. There is a printing mistake, the typist problem. This is the answer. Okay, guys. Understood? So yeah, it is coming out to be this one only. That was typing mistake by the typist only. So please ignore it. My humble request. Meanwhile, please do it. What's wrong with my approach? एक्चुअली आपने इरिवर्सिबिलिटी निकाली. इरिवर्सिबिलिटी है क्या? वर्क मैक्सिमम माइनस वर्क एक्चुअल. बट यहाँ पे ना मैक्सिमम वर्क है ना एक्चुअल वर्क है. मैक्सिमम वर्क में आई मीन वी हैव टू चेक द डिफरेंस बिटवीन मैक्सिमम वर्क ओनली. इट इज नॉट मैक्सिमम माइनस एक्चुअल. गॉट इट? आर यू गेटिंग माई पॉइंट? सो योर इफ यू गो विद दिस इट विल बी maximum work minus h1 minus h2. That is your difference, but that is not correct. It is asking what is the difference if at initial location you have maximum and at final location you have maximum. What is the difference between those two maximum values? It is asking that. Got it now? Got it? Next question. The geothermal water extracted at 160 degrees Celsius at a rate of mass flow rate used as heat source in a geothermal power plant. It produces 22 megawatt of net power. 22 megawatt of net power. If the environment temperature is 25 degrees Celsius, T naught, right? Power, P net, T naught, and specific heat. What will be the actual thermal efficiency, maximum possible thermal efficiency, and actual rate of heat rejection? It's a good question. Please do this. It's a good question. Please do this. यार लॉस इन अवेलेबिलिटी उसमें होता है इरिवर्सिबिलिटी जब तुम्हारा वर्क आउटपुट हो. नोजल से कहाँ से वर्क आउटपुट आ रहा है ये बताओ ना मुझे. नोजल से वर्क आउटपुट आ रहा है क्या? आर यू गेटिंग वर्क आउटपुट फ्रॉम द नोजल? नो ना. If you are not getting work output from the nozzle, then how can you say that work output difference is irreversibility? है ना? What is irreversibility? Irreversibility is maximum work upon minus actual work. What is being asked? In a nozzle, change in availability. Is it done, everyone? Ajmal. So is it done? No? B. Okay, let's see. Shall we do it? Shall we do it? Please tell me. Shall I do it? Say yes or no. Shall I do this question? Please do let me know. Very simply it can be done. See, there is a geothermal extraction, blah blah blah, this that. Okay. So it is saying the specific heat of water. What will be the actual thermal efficiency maximum? See, rate of heat supply equals to del Q equals to delta H, because it is coming in with some enthalpy and going out some with some enthalpy. It's coming in with 440 kg per second into specific heat 4.22, and the temperature differences are extracted at 160 minus surroundings is at 25 degrees Celsius. Great. Now, so the rate of heat supply rate Q dot S, this one shall be (250.668) megawatt. Great. Now Q dot rejection will be this much is being supplied, right? This much is being supplied minus whatever power output you are obtaining. So it will be 250 minus 250.668 minus 22. So the answer shall be Q dot R minus 228.668, or yeah, 0.7. So option number B. If you want to do, you can do for yourself. Efficiency actual, that is work over or power over Q dot S, that is 22 upon 250.668, that is 8.8%. You can check for yourself. And maximum efficiency would have been, if it were a Carnot cycle, 1 minus lower upon higher, that means 1 minus 298 over 160. Oh, 60 is 333, 1433. Neta maximum. So neta maximum would be 31.2%. Got it now? Got it now? Hello Sahil, how are you? So is it done? 31.2%. Amit Singh Gurjar. Chaliye, is it done? Please do it. Understood or not? It's a straight away question. No much hodgepodge is there, right? It's a straight up question. I hope it is clear. I hope it is clear. All right. Shall we move ahead? Next question. Consider a piston cylinder device which initially contains helium gas at 150 kilopascal, 20 degrees Celsius, and this much means pressure, temperature, and volume is given. If the helium is compressed in a polytropic process, oh my god, this is not given. Polytropic process, let me check with me. Please try this question till I'll be finding the data. Just a minute. Just the equation is not given. PV to the power n equals to constant. Try this question out. Try this question out. I'm giving you some time. Please try it out. Try this question out. I'm giving you some time. Done? Done or what? Please tell me. It is a classic question of first law of thermodynamics. It's a classic question of first law of thermodynamics. Yes. Value of n. Can't you calculate? See, this is helium, no? R is given. M can be calculated. PV upon RT. Everything is given. You can calculate M, right? Okay. Now, T is given. Over here, mass is there. Mass is known already, R. Can you calculate V over here? Can you calculate V over here? Yes or no? P2 V2 is equal to MR T2. So can you calculate V2? MR T2 upon P2. Now P1 V1 to the power n equals P2 V2 to the power n. P1 P2 V1 V2 known. N can be calculated. Yes or no? Simple. Understood now? Understood? You want me to do it? You want me to do it? Let me do it. Let me calculate the mass. 150 times 0.3, 0.5 sorry, times PV upon RT. R is 2.0769 times T1 is 293. Okay, M is pretty much known to you. 0769 times 293. So it's 0.12325 kilograms. Now V2 can be calculated as M is 0.12325 times 2.0769 times what is T2? 140. So I believe 140 shall be 313413 over how much is the P2? 400 kilopascal. Great, let's do it. So the value for V2 we'll know. How much is the value for V2? Into 2.0769 times 413 by 400. 2643. 0.2643 meter cube. Great. Now the value for N will be ln P2 over P1 ln V1 over V2. So this shall be ln P2 is how much? 400 over 150 divided by ln V1 is how much? What is V1? 0.5 over 0.2643. Yes or no? So the value of N will come. $1.538. That is your value for N. Now can you calculate work? Now can you calculate work? Now can you calculate work? Calculate work. It is P1 V1, P2 V2, N minus 1. P1 is how much? 150 into 0.5 minus what is V2? P1 V1, P2 V2. P2 is 400 into 0.2643 over N minus 1. Am I right? N minus 1.5384 minus 1. That is your work. Work will come out. Let us see, work will come out. Let's say how much it is. Times 175 minus 400 into 0.2643 minus 57.05 kilojoule. Yes, that is your work. Now delta U we can calculate. M CV delta T. What is M over here? 0.12325. CV. How much is CV? CV is given 3.1156. And delta T, how much is delta T? 140 minus 20. So it will be, let's check. 3.1156 0.12325 46.08 kilojoule, and I believe del Q shall be 46.08 minus 57.05, and this would be 57.05 10.97 11.2. That is your del Q. Yes or no? Check it. That is your answer. Kindly check it. Am I right? It's something like this. It is coming. Okay. Understood, everyone? Option number D. Understood? It's a classic question of first law of thermodynamics. Got it, everyone? Please take a note of it or take a screenshot. Then we shall be moving forward. Kindly take a screenshot, then we shall be moving forward. Okay? Are these questions good enough for you? Yes? See, air is compressed adiabatically from P1, T1, P2, V2. V2 is given this time. After this, air is cooled at constant volume. There are two processes. One is adiabatic, the other one is constant volume. 2, this much. And at this temperature, the specific heat remains constant. Neglect the kinetic and potential energy changes. Assuming, what do you have to assume? Ideal gas behavior, the work for the second process and the heat transfer for the second process respectively will be. Do this, that's a good question. Do this question, it's a good one, please do it. Understood, everyone? Shall I deal with this question? Shall I deal with this question? Let me deal with it. See, air is compressed adiabatically from, it is not from, it is actually from P1, T1, P2, V2. Okay. So your P1 is given 1 bar, T1 is given 300 Kelvin, and 2, P2 is given as 15 bar, as well as V2 is given as 0.1227 meter cube per kg, not meter to the power 4. This much correction you can do, right? Okay. And this is in adiabatic, 1 to 2. Then you have isochoric. What is isochoric? Cochoric nahi, isochoric. In isochoric 2 to 3, what is happening? Constant volume, and V2 equals V3. Yes or no? V2 equals V3 means 0.1227 meter cube per kg. And also T3 is given as T1. Why? See the value 300 Kelvin. Tada tada. Okay. Here work done will be 0. Arey Baba, here work done will be 0. Here heat transfer will be 0. Yes or no? So it is asking neglect kinetic potential energy changes. We don't have to do anything with the kinetic potential energy changes. What do we have? Work for second process and heat transfer for the second process. Right? So work for the second process is not there. Heat transfer for the second process is there. So, and according to the option, this should be heat for the second process. Just a minute. Work for the first process and heat for the second process. Okay. If it is adiabatic, work transfer is how much? Apply first law. Simply apply first law. What do you get after applying first law? Once you apply first law, it is del Q equals du plus del W. For sure, heat transfer is 0. 1 se 2. For sure, the transfer of heat is 0, my dear students. Yes or no? If that is the case, then del W 1 to 2 is minus du. Means CV delta T. Is it clear? That is CV delta T. CV is given as 0.718. How do you find out delta T? Right? How to find out delta T? How to find out delta T? Temperature at first step is given. Now you want to calculate temperature at second step. Right? So air it is given. Please pay attention. Reversible adiabatic process. Yes or no? Reversible adiabatic, T2 equals T1 times P2 by P1 to the power gamma minus 1. Gamma minus 1 upon gamma. That is T1 is 300. How much is P2? P2 is 15. P1 is 1. 15, 1. Alright. 15, 1, 1.4, 1.4. So our T2 will come. Let's see how much is T2. Let us see how much is T2. You understanding what is being done over here? Tell me, guys. Please tell me. $650.35. This is our T2, right? 650.35 minus 300. That is our work done in minus terms. So work done shall be, because it is compression or input, that's why y minus we can remove. 0.718. 251.55 kilojoule per kg. That's right. Work done is there. Now, first law for 2 to 3. Del Q equals du plus del W. Work done is absent, so del Q shall be du. Now what is du over here? CV delta T. Now CV, what is the final temperature? T3 minus T2. T3 minus T2. CV is 0.718. T3 is equal to T1. We have seen this already, right? That is your 300 minus 650.35. Del Q shall be I think it is coming out to be the same. That is 251.55 minus 251.55 kilojoule per kg. So option number C, both of them have the same value. Got it? Both of them have the same value. Understood now? Good question, right? Please tell me. Is it clear, everyone? Is it clear, everyone? Please tell me. Done? No problem. Next question. Shall we move? This is the next question. Consider a rigid vessel of 0.3 meter cube which initially contains saturated liquid vapor mixture of water at 150. The water is now heated until it reaches the critical state where specific volume becomes this much. At 150, the specific volume of liquid is this much, and for gas is this much. What is the mass of the liquid water? This is from properties of pure substances. Try this question, please. Done, yes or no? Let me deal with this question. हाँ, आपका रह गया है क्या? I mean, is your syllabus remaining? See, what is happening here? A rigid vessel is there. Rigid means volume is fixed. Initially contains saturated liquid vapor mixture of water at 150 degrees Celsius. Water is now heated until it reaches critical state. So the final volume is, specific volume is this much. At 150, this much is given. What is the mass? So if you want to calculate the mass of liquid water and the volume occupied by the liquid at initial state. So see, total mass of the mixture. How much would have been? Total volume upon specific volume, be it V2 or V1. But V2 is what? Vc. It is given critical. So I believe total mass is MT is 0.3 over 0.3 over 0.003106. That is your total mass. That is your total mass. Let's see how much it is coming out to be. 0.3 over 0.003106. 96.578. 96.587, sorry, kg. Am I right? This is the total mass. Now, if we are able to see at final stage, that is 150 degrees Celsius, dryness fraction is how much? Dryness fraction is how much? Dryness fraction, what is the value for dryness fraction? Right, it is heated until it reaches a critical state. Right, at critical state volume is this much. So it is at final state. At final state, what happens? How can we find out the value of dryness state, dryness fraction and all? So if we want to find out the value for dryness fraction, go with the value for density. Check. 1 by density or specific volume per se is Vf plus X Vg minus Vf. How much is V finally? How much is specific volume? 0.003106 minus, what is Vf? 0.001091 over, what is Vg? 0.39248. 0.001091. Let's see how much it is coming out to be. 0.003106 minus 0.001091 over 0.39248 minus 0.001091. 0.00515. That is your dryness fraction. How is dryness fraction given? Mass of vapor upon total mass. So I believe mass of vapor shall be into 96.587. .4972. Right? 0.4972 kg it is coming out to be. Yes or no? And if I subtract it, 6.587, that is 96.1 approximately. But with 96.1, yeah, mass of liquid is asked 96.1. So we have two different masses. Either this is wrong, then this is wrong. Either of them. Now, volume occupied by the liquid at initial state. What is the volume occupied at initial state? So if dryness fraction is given, we can very easily find it out and solve it. Tell me yes or no. Tell me, guys. Can you do it? Hmm? Yes or no? Are liquid mass is given, no? Multiply it with this one. Multiply it with this one, no? How much is this? 0.001091. 0.108 something. 0.1048. So this is the correct one. That is the wrong one. Right? Volume of liquid is ml into Vf. You get this answer. Understood, everybody? Understood, everybody? Say yes or no. Kindly tell me yes or no. Is it done? टोटल मास कैसे निकाला? फाइनली क्रिटिकल तक पहुंच रहा है, राइट? टोटल वॉल्यूम अपॉन दिस, बिकॉज टोटल वॉल्यूम इज नॉट चेंजिंग. गॉट इट ध्रुव? डू इट. Very beautiful question indeed. Right? Yes. अब देखना, the last question of the day, we are going to deal with that, and that is at another level. This question, it is amazing question, and this is your homework question. You have to do this. Okay, it will be discussed in my 10 Hindi questions. You have to tell the answer in comment box. And my 10 Hindi questions for thermodynamics will be different, right? My 10 Hindi questions for thermodynamics will be different. In that, I will discuss this. Okay? In those questions, I will discuss this. Try it out. Try this question out. Try this question out. It's a very beautiful question, my dear. Try it out, please. Try this question out. Shall I deal with this question? It's a very good question here. It's a very good question indeed. It's a very, very, very good question indeed. Shall we deal with this? Or you want to try first? Try this out first. Then we are going to deal with it. Okay? Take your time. Please, take your time. Shall I deal with this now? Good. Come on. Let's see. See this question. So in this question, P1, T1, P2. Can we calculate T2? Of course we can. T2 is T1 times P2 over P1 to the power gamma minus 1 over gamma. So air is there. 180 means 7, 8, 53, right? 353, 453. Final pressure is 100, 300, 1.4 minus 1 upon 1.4. T2 shall be now. Let's calculate the value for T2. That is 0.7 into 453, 330.96 Kelvin. This is it. Great. We have obtained this now. Am I right? Inlet velocity of air is low, means negligible. Low means it is saying it has another way of saying that it is negligible, right? Now this is T2s actually, right? Isentropic temperature. Steady flow energy equation, because it is having steady flow only. So it will be H1 plus V1 squared by 2000. The nozzle is adiabatic, potential energy change is neglected. Simply I can say H2 plus V2 squared over 2000. Am I right? So I believe this is 0. V2 over 2000 shall be equal to what? Delta H of isentropic condition. Yes or no? Or I should rather say H1 minus H2 of isentropic condition. So this is based on isentropic. V2s is what? Velocity based on isentropic process. Right? V2s is that. Okay, no problem. So similarly, what is isentropic efficiency? Where is it? 96%. Isentropic efficiency, neta isentropic, that shall be delta kinetic energy actual upon delta kinetic energy ideal or isentropic. Am I right? So delta see, this is 0.96 equals to delta kinetic energy actual over, how much is this much? Cp 1.005. What is final temperature? Initial is 453 minus 330.96. That is it. So delta kinetic energy actual will come. Okay. Yeah, it is 117.157 kilojoule per kilogram. No problem. No problem. So I can rather say that V2 squared actual minus V1 squared over 2000 is actual 117.157. And this is tending to 0, we have seen already. So V2 actual equals to 2000 times 117.157 under root of that. So V2 actual shall be 484.06 meter per second. Now, which is the most close to this one? Closest. Go with this. Understood? Clear, everybody? Say yes or no. Is it clear, everybody? Please tell me yes or no. Please tell me yes or no. Is it clear, everybody? So this, my dear students, will be the solution to this question. I want you guys to please take a note of it. I need you guys to please take a note of it, and then we shall be moving forward. Kindly do it. Okay. So these were your 10 questions, 10 important questions, 10 very good questions, and 10 questions which have pretty much significance, and they have a very good possibility or good chance of coming this year in GATE 2022. Got it? You want next question screenshot? Please have this question. I want the solution or the answer to this question in your comment box. I want everybody, those 11 of you who are watching, at least those of you have to answer it. You have to participate. And I'll be discussing it in my 10 questions next in Hindi language on the main channel. That is GATE Academy CE, ME, XE, PI, so on. Okay, guys. Understood? Thank you so very much. It was pleasure having you all as usual. And I attempted to give you the best of the questions and best of the experience. Please do let me know how you felt. Right? I think you might be feeling good. So, see you guys in the next lecture or the next my 10 questions. And all of the questions which I'll be dealing, if I'm dealing in dual languages, the question shall be different. Right? I won't be dealing with the same questions, set of questions all the time. My set of questions will be different every time. Okay? Video is not going to be private. Don't worry. Video is not going to be private. So just chillax and have fun. But in the next class, please try to be live and share it as much as possible. Chalo, bye-bye. Take care. Jai Hind. Love you guys. To the moon and back. Do take good care of yourselves. Bye-bye.